So I'm going to work through it the way that I would do it, and it doesn't mean it's the only way to do it, by no means. There are always lots and lots of ways to do it. And sometimes I don't pay much attention to what they're asking for in the problem. I just find what I can find, and then once I've found something, I see, okay, well, now what else can I do? And so that is often what I do, and I try to do things the same way I have them done in my notes, but I seem to have lost my notes. I have some old notes. I probably won't end up doing them the same as that either, and then, so what that means is that I am likely to make multiplication and arithmetic mistakes, so just keep an eye out for that and let me know if I've done that. Okay, so I'm going to start with this circuit, and I'm supposed to find various things out about this circuit, and the tools at my disposal are in KVL and KCL, and so I want to set up some equations to do that. So the first thing that I see is that I've got this node right here on top, and I've got 3 currents involved with that. I have IX going towards the node, I have I1 coming out of the node, and then I have another current. I don't know for sure what direction it's going. I can draw it whatever direction I want. I will draw it going down, and I'll call it I2. And then when I get my answer, that'll tell me whether it is actually going down or going up, depending on whether it is the answer I get is positive or negative. So I can say that at this top node, using KCL, so KCL tells me that the current, the way I look at it is I say current in equals current out. To me, that's real easy to see because it just kind of makes sense. Everything coming in has to go out, and that's the way I write it. The other way to do it, which is I think the way the book does it, is to define all currents as positive if they're coming out. Not to define them as positive, but to do all currents as if they're coming out of the node, and then say they have to sum up to 0, meaning some have to be positive and some have to be negative. To me, it's easier just to see current in equals current out, and that's based on how I have them drawn. So the way I have them drawn, the current in is IX, and that has to equal the current out, which would be I2 plus I1. Now, usually we don't use the actual currents in our KCL equations. We are going to write them instead often as voltages, and I'll show you what I mean by that in a minute. So one thing that I find useful to do, and that you should always do, is to set a reference node. So I'm going to set the bottom of this as ground, and then it helps me to then label the other voltages at the other nodes if I can, if I have enough information about them to label them. So, okay, I'm glad I went back and read the problem, because I often do this. I'll work this, say, I don't have enough information to do it, and I have to look, and it tells me right here, it gives me some information right there. So I know that IX is 50 milliamps, so IX is 0.050 amps. And Vx is 3.5 volts. So that means that since the top is plus and the bottom is minus, the top has to be 3.5 volts bigger than the bottom. Now, if I made the bottom ground, then I can make this up here 3.5, because that's what Vx is. Now, similarly, I don't know what V1 is. That's something I'm supposed to find, but I know that across this resistor, it is labeled V1. So that means the plus side has to be V1 more than the minus side. The minus side is 0, so this plus side has to be V1. And similarly, this voltage source over here is VG. So the plus side has to be VG more than the minus side. So it's going to be like that. Okay, Now, let's see, I'll go ahead and replace Ix with 0.05. So I have 0.05 equals I2 plus I1. Now I'm going to use Ohm's law. So Ohm's law tells me that we say it's V equals IR, but it's really delta V equals IR. And so when I have a current, like in this example, I have Ix going in this direction, and I have on this side VG, and I have on this side V1, and Ix is going in this direction, then what this means is that VG minus V1, so it's the change in voltage across this resistor, equals Ix times 50 ohms. Ix we know is 0.05, so we have Vg minus V1 is 0.05 times 50 ohms, which should be 2.5? Should be 2.5. And 2.5 volts. Okay, so this is I think I have the wrong notes altogether. Oh no, I don't. All right. So now let's see what else we can find. So now we know the voltage change across. We know what VG minus V1 is. Now let's use some KVL. And I will use let's see. Actually, before I do that, I'm going to write down what I1 and I2 are in terms of voltages. So when I'm writing a current, and so this is from Ohm's law, when I'm writing a current, it'll be the voltage where I start, so VA minus the voltage where I end, over the resistance. So in going in the direction of the current, the voltage on one side minus the voltage on the other side over the resistance. So I can say that I2, which is the one going down that middle branch, equals V1 minus 0 over 250. And I can say that I1 equals V1 minus 3.5 over 200. And actually, I think that's all I need on this one. I don't think I need to do any KVL, because now I can plug into this equation. So 0.05 equals V1 over 250 plus V1 minus 3.5 over 200. Let's see, so now I will I'll multiply everything through by well, let me just multiply let me do it like this. So I will get 200 multiply everything through by, well, 1,000 will certainly work, so I'll do that by 1,000. So that will give me on this side 50, and then 4v1 plus 5v1 minus, and 5 times 3.5. $17.5. So 67.5 equals 9v1, or V1 equals whatever that calculator just said, 7.5 volts. Okay, so I'm going to pause for just a second to see if anyone has any questions on what I've done so far. All right.
Is this the same, like, would you call it a simple question if you just do, like, the loops, like what he's
Yes, absolutely.
does?
Yes. There's no one way to do things, and I think in my notes I did the loops. I'll try to do the loops on the next one. But there's lots of ways to do it. So essentially what I did right here was the loops, and I'll show you why when we get to the next one. So so we have that V1 was 7.5. And now that we know that V1 is 7.5, the fact that I have my I1 already defined for me right here, so I1 equals 7.5 minus 3.5 over 200, or 4 over 200, or 2 over 100, or 0.02. Yeah, so 0.02 amps. So I1 equals 0.02 amps, or you could say 20 milliamps. So that was the second question. So 20 milliamps. Now we need to find VG. So let's see what we've got that will help us with VG. So we already have that VG minus V1 equals 2.5 volts. VG minus V1 equals 2.5 volts. VG minus 7.5 equals 2.5 volts. And so VG equals 10 volts. And then the last question was the power supplied by the voltage source. Okay, so I want to look at the power supplied by the voltage source. And so I know that power equals the current times the voltage. And I want to look at the current as it's going into this voltage source. It's going into the negative side of the voltage source. And the current that's going into it is IX. So IX was 50 milliamps. So that's 0.05. And it's going into the negative side, so I'll make that negative. And the voltage was 10. So negative 10. So that ends up being negative 5 watts. Or negative 0.5 watts, sorry. Negative 0.5 watts. And so the power supplied by the voltage source is 0.5 watts. You don't say that negative 0.5 was supplied. The negative means it's supplied, but you don't say that negative was supplied. Okay, so what I'm going to do now is I am going to take this same circuit. Actually, I'm sorry, I go too fast. Let me make sure everybody's ready for me to go on. I'm going to look at this circuit and do it another way so you can see that there's lots of different ways to do it. So, where's my chat?
So when we're finding the individual voltages, we're just taking like across the resistor, like what each thing is.
Yes. And that is really important because people a lot of times use the wrong voltage. They'll just see a voltage and use it. You need to make sure that you're using the voltage across that resistor.
Okay, thank you.
Yep. So the problem with Ohm's law is it's so useful in V equals IR, and we're so used to using it that a lot of times it's easy to use the wrong V, and you have to make sure that you use the right V. So, okay, so I'm going to redraw this circuit. Yeah, this was Vx, but that was given. That was, and this is 175 ohms, 200 ohms, 50 ohms, Vg, Ix, 250 ohms, plus minus V1, plus minus Vx. Okay, so now let's do this. Okay, and we know that Ix was 50 milliamps, and we know that Vx is 3.5. Okay, so now let's take some loops. So now I'm gonna do KVL. So I'm going to take I'm depicting the left-hand loop for no particular reason. I'm going around that one. Now, as I go into the minus side of this voltage source right here, I call that minus Vg. And then going across a resistor, your voltage is going to be your current times your resistance. So that is Ohm's law, so V equals IR. And I want the voltage across that resistor. So I want exactly what I have right here, the current times the resistance. And my loop is going in the same direction as my current, so it will be whatever Ix is, which is 50. So I don't change the sign or anything like that. Well, it's really 0.05 times 50 ohms. So that's the voltage there. And then plus, I will say V1 right there, because I don't know V1 yet. Or if I noticed I didn't draw another current in on this one, so I could, if I had drawn another current in like I did on the first one, I called it I2, I could have written this as I2 times 250 ohms, but I didn't, so I have it like that. So I have that one. Then I can take another loop. Let's see, let's do a loop around this second loop here. And I know what Vx is, so I don't have to, oh, and I have another current up here, this is I1, that way. I don't have to do anything extra along this Vx, I already know that's 3.5, so I have 3.5, and then minus V1, and the reason it's minus is I'm going into the negative side of that one, so minus V1. And then across that 200 ohm resistor, that will be plus I1 times 200 ohms. And that has to equal 0. Okay, so I have two equations, but I have three unknowns, so I can't solve them yet. Now, so in order to solve them, I'll need some more information. So I can also get that let's see. So I can do, the third loop is not going to help me here. If you have this circuit has a total of 3 loops. It's got the right loop, the left loop, and the loop all the way around the outside. And if I've used 2 of those 3, the third one does not give me any more information. So I have to do something else here, a KCL or maybe an Ohm's law. Let's see. Let's see. I think I can't. Yes, I could. So this I1 right here, I can replace that with something in terms of V1, because this is V1. If I make this ground, then I have V1 up here, and I can say that I1 equals V1 minus, and remember we said this would be 3.5, minus 3.5 over 200. Oh, that doesn't help us, because look, if I plug that into here, that just gets me a true statement, so that doesn't really help. So if I plugged it in, that would just give me, I would get 0 equals 0, so that doesn't help. So I do need to do KCL, and usually you will have to do a KVL and a KCL on every problem. So I am going to end up needing to draw in this next current, and I can call that current I2. And so my KCL tells me that IX equals I1 plus I2. And I know IX, so that's 0.05 equals I1 plus I2. And then I would need to replace I2 with so it's like, it seems like, okay, well now I just introduced yet another variable, but I can say that I2 equals V1 over 250. So now, not V2, V1. So now I have this one has I1 and V1, and this one has I1 and V1, so I could solve those two together. So I have negative 3.5 minus V1 plus 200 I1 equals 0, and I have 0.05 equals I1 plus V1 over 250. So for this bottom equation, I'm going to multiply everything through by 250. And 12.5 equals 250 I1 plus V1. And that's this, the second equation. The top equation, I would have, let's see, if I leave this, if I take the 3.5 to the other side, I have 3.5 equals 200 I1 minus V1. Then I can add these together. My V1s cancel. I get 450 I1 equals 16. And I made a mistake somewhere. Did anyone see where I made a mistake? Okay, let's see. I1 V1 minus 3.5 over 200, that looks good. 0.05 equals I1 plus I2, that looks good. I2 is V1 over 250, that looks fine. Then
Wait, why is it 250 I1 again?
say that again?
250 I1.
250 I1 right here, because I multiplied this equation through by 250. So I took this equation right here, which was 0.05 equals I1 plus V1 over 250, and I multiplied everything through by 250. And if I did that correctly, that was 12.5, and then 250 times I1 was 250 I1, and then 250 times V1 over 250 is V1. So that's where that came from. Does anybody see anything else that looks like it might be wrong? Let's see. So on this loop, I had 3.5 minus V1 plus I1 times 200. What did we get for I1 last time? We got 0.02? Okay.
Yeah.
Okay, so, and that is right. The 0.02 is right. So minus 3.5 minus V1 plus 200 I1. Okay, I, I don't I don't know what I did wrong. I'm sure I did something wrong, because it would ordinarily work. So let's see. If anybody else has any questions about something, it's probably, it would help me figure out what I might have messed up. Let's see. So I have IX going in, I2 and I1 going out. I2 equals V1 minus 0 over 250. Did I copy the circuit right? That's 200, that's 175. Vx is 3.5. Is it because this is not, did I make that a negative 3.5 when it was supposed to be positive? I think that's what I did. Yep. Yep, that's what I did. Okay, so up here, I was just misreading my handwriting. That's not really a negative 3.5. That, so that should not have been negative, which means when I take it to the other side, it is negative. So now when I take 12.5, I told y'all I make these, and this is what I get for like going out on my own and saying, oh look, it'll work the same if I do it another way. I will certainly make arithmetic mistakes, so you have to watch me on that. Okay, so this should have been a negative 3.5, which means this should have been a 9, and now when I divide 9 by 450, I get that I equals 0.02 as it was supposed to equal. So that was so that is I, and so that's I1, and then you can go through and find the other things as well. So that was showing that you can do the same problem in multiple ways, but it really is helpful if you don't make mistakes like I make. Okay, so are there questions before I go on to another problem? All right, let me save this one.